My name's Brian Harry, and I'm responsible for Team Foundation Server. And the talk I'm going to do today is a talk called Lessons from the Cloud, which is just a little bit, sharing a little bit of our experiences that we've gone through moving TFS onto Azure and into the cloud. It's not really about TFS per se, so I'm not going to talk about any features of TFS or how cool it is or how everybody ought to use it. But I'm just curious, how many of you are using TFS? All right, a few. Doug Newman's going to do a talk on Thursday, I think, where you can actually see TFS in the cloud. I'm not going to show you TFS in the cloud. This is really more of a talk about kind of the things you should think about when you're moving an app to the cloud, and the sort of experiences we've had and lessons that I've learned. So my background, I've been doing software now for almost 25 years. And my background's, classic shrink-wrapped ISV for as long as I can possibly remember, and have been used to the very standard cycle of shipping shrink-wrap products in startups. We did it, like every 6 months, but it was kind of the same process. And at Microsoft, we do it, like every 3 years. But the fundamental mechanics are the same. And cloud's different. So I'm going to talk a little bit about it. So agenda, I'm going to start with a little background of hosting TFS at Microsoft. Because that's kind of my first experience running a service. Is we've got we host TFS for Microsoft, and I learned a lot from that. Then I'm going to talk about porting TFS to the cloud and some of the hard problems. No way in 45 minutes can I cover all of the interesting topics around the cloud, so I've picked 3 that I think are particularly interesting. And most of my talks are pretty frank, sometimes brutally. So I will be brutally honest with you about the state of some of our cloud stuff. So background, hosting TFS at Microsoft. We started in 2005. Actually, it was November 2004, but close enough. And it started with about 80 people and has grown and grown and grown. Now it's almost 30,000 users at Microsoft on TFS. It's a pretty standard IT-hosted service. We have first-tier support, second-tier escalation, and third-tier goes to the product group. It's sort of characterized by a small number of large projects. I did a little math the other day because I was just kind of curious. The average TFS project at Microsoft has 15,000 source code files in it, and that's the average. The largest are, hundreds of millions. It's kind of crazy. But the number of work items, I don't remember the number, but it was 3,000 or 4,000 average work items per project at Microsoft. So it's comparatively small number of very large projects. And the dev service, that's the TFS server that developer division uses. It has always been the single largest server at Microsoft, and quite honestly, I think the largest TFS server in the world. Last I checked, it was around 17 terabytes, so pretty sizable. And it was always our canary. Like, whenever anything was not quite right, dev would fall over. And we went through some pretty painful periods, which I'm going to talk about. So Microsoft, just to give you an idea of the growth, Microsoft has 45 TFS instances set up. And what is that? 7,573 team projects. So when I say a relatively small number of large team projects, okay, 7,500 is kind of a lot, but compared to the cloud, it's not very many. Active users, 26,460. And this date is actually May, so it's 6 months after that. We're, I think, at around 29,000 now. Total work items, nice wrapped number, 9.8 million. And total source code files, 108 million. So pretty big installation. So, kind of my biggest learning from that experience was we in 2008, we moved all of developer division. Until then, it had just been sort of a few teams in developer division, which is to say about 600 people. But we finally moved all of developer division onto TFS. and it collapsed. It was an awful experience. The whole thing just fell over. We had huge performance problems. We had huge availability problems, and we set to work on righting them. And by 2008 SP1, we had fixed most of them. By 2010, we had finally reached stable, steady state, and everybody was happy again. But I learned a bunch of lessons from this. The first one was that you can't simulate production. In fact, in the cloud, sort of there's this cute little catchphrase that people use. They say, there's no place like production. And what that means is there's no way to simulate it. Like, you could try, and we did. Like, before we did this DevDiv rollout, we had spent months creating load tests, simulating thousands of users, doing all kinds of stuff. We had modeled based on previous systems. We sort of did everything we thought we could do to be pretty confident that it was going to be able to handle the load. And nonetheless, I mean, literally within a day of it going up, boom, it fell over. And the reality was our simulation just wasn't accurate. And it is very, very hard to create a truly accurate simulation. So ultimately, there really is no place like production. You're never going to find all your issues. Now, we've learned a lot from it, and our simulations have gotten better. And I'm not saying by this, don't try to simulate, because you have to. You've got to do some amount of validation. But what we've learned is that validation isn't enough. You've got to use some other techniques, which I'll talk about in a little while, to mitigate that falling over experience. The next thing I learned from this is that your users will know about your problems before you do. I don't care what you do with monitoring, and I'm not saying don't do monitoring. Yeah, you should do monitoring. But I don't care what you do. Your users will know before you do. You know how I knew in 2008 that the server was down? Within about 2 seconds, I had email in my inbox from somebody telling me the server was down. Literally, it was about 2 seconds. And our monitoring was, I think, I don't remember, it was every minute or every 2 minutes that we'd ping the server and see if it was alive. I mean, you can't ping it every millisecond because, well, then that'll knock the server over. So literally, it was about 2 seconds. Because you got 3,500 people using the server, and you can be pretty sure that somebody's hitting it pretty often. And once it's been down for on and off for a couple weeks, they don't even bother to wonder whether it's something wrong with their computer. They just shoot you a mail saying it's down again. The other thing I learned is communication is key, before and after. So after is easy to understand. If you have an incident, communication is really important about how you communicate about the incident, what you're doing about it, what the plan is, and especially if you don't have a great answer like, hey, we know there's a problem, we don't know what it is yet, but here's what we're doing, and here's a time frame in which we'll be able to update you again. It's how do you communicate before you have a problem when you don't know you're going to have a problem? What I really mean by that is there are, what drives problems? The number one thing that drives problems is changes. Something changes. Often it's change in configuration, change in software version. It can be change in usage pattern, change in number of users. So it's really important to communicate to your base whenever you're making a major change to the system that you are making that major change and that there could be some disruption, and try to work with them. So we've gotten into a model now that anytime we're going to update the DevDiv server, we work with the division to understand sort of when's a reasonable time that, like, say, isn't the day before we're cutting the final build for a release, to make sure we're okay. Another thing I learned is the app is ultimately responsible for everything. So, I can't tell you, through this experience, when I say TFS fell over, it wasn't just TFS. We hit bugs all throughout the stack. We hit an IIS bug, we hit a Windows file system bug, we hit a network stack bug, we hit all kinds of problems all throughout the stack. TFS at that level of load was just such an unbelievably demanding application for the entire software stack that problems popped out. And so, someone would say, hey, the server's crashed again for the third time today, and I'm really pissed about it. And I'd say, yeah, the file system hit a deadlock and locked up the server again. And they don't care. Like, nobody cares that the file system deadlocked, and they don't care that the Windows escalation team is working really hard on it, and you've provided them 27 crash dumps so far, and they haven't figured it out yet. All they know is the Exchange server isn't falling over, so why is TFS falling over? You must be doing something wrong. So ultimately, when you're the app, you're responsible. I found ops discipline makes a huge difference. When we first started, we had a very immature ops team that really didn't know how to run a service, wasn't sort of skilled. They weren't skilled in SQL very well. Didn't understand how to tune a SQL server, how to health monitor a SQL server, how to say monitor available disk space on the drives. Can't tell you the number of times we ran out of disk space. They just weren't a very rigorous and mature ops team, and that was a source of a bunch of problems for us. And I really came to appreciate a good ops team that knows what the heck they're doing. Next, pace your growth if at all possible. After sort of this experience, I developed a rule, which is I will never grow load on any production server again by more than 10x in any one increment. Because you just have no idea what's going to happen. So I talked about mitigations for simulation. That's one of them. Don't grow by more than 10x. So if anybody wonders, so if you've seen, how many of you have seen anything about the hosted TFS service out there, tfspreview.com? Okay, a few of you. So we've got a hosted TFS server out there. You can go look at it and try out TFS in the cloud. You need an invitation code to get there. So you've got to sign up and type in this funky little invitation code, and we've been handed out a pretty fair number of them, but we've been fairly controlled about it. Why? Because I'm not going to grow this. I'm not going to just open it up and let the service go wild and let 100,000 people all sign up in one day and watch the service fall over. The primary reason for that is to control the speed of onboarding, so that I know I can work with the server, figure out the issues as load increases, and make sure that by the time I tell the world, it's ready to go live, I know that I'm not going to be 100-fold bigger within a week. And then lastly, always have a plan. Big thing I learned from DevDiv was round about every 10x increase in capacity and load and in whatever, the rules change. Like you just cannot predict what the ramifications of that are. And everything will be running along fine, and then all of a sudden you hit a bottleneck. And I developed a rule that I was always going to have a plan. Like whatever level the server was at now, like whatever capacity, capability it had, I always knew in the back of my mind, if I needed another 50% capacity, I knew what I could do to go get it. Some relatively straightforward code investment, configuration change, hardware change, something that would give me a 50% increase whenever I needed it, because you never know when you're going to hit your limit in sort of a surprise, and you got to be ready for it. So that's kind of my learnings from that. So now let's talk about the transition from internally hosted service to the cloud. So I was going to start with why cloud. Why is cloud interesting? Why did we decide to put TFS in the cloud? Well, there are a bunch of reasons, and I don't know that this is an exhaustive list, but it was what came to my mind as I was writing this slide. Number one is the number one support issue for TFS today is setup and reconfiguration. People have the wackiest LAN configurations, domain trust configurations, firewall configurations, topologies, administrative trust relationships. Everybody's got something different. And trying to figure out all of the ins and outs of every single one of those, and further add to all those weird configurations the changes they want to make. Oh, I've got TFS spread across these 3 servers, different components, and now I want to consolidate them onto one server in a different domain. And by the way, none of the users in the old domain have access to the new domain anymore, so I need to translate all the users in the old domain to new users in the new domain. Oh my God. Trying to figure out how to do all that and walk a user through it who's never been through that kind of thing before is a nightmare. And with TFS in the cloud, you don't have to worry about it. Like, it's in the cloud. We take care of it. It's all done. So that whole support burden, and when I say the number one support issue, I don't mean like it's number one because it's 20%. I mean it's number one because it's like 2/3 of all support issues. So it's huge. It's a dramatically easier getting started experience. Nothing to install. You just go up there, sign up. I think it's like 2 minutes tops. If it's a good day, it's like 30 seconds. Sign up, create your project, and get started. It's easier for cross-geography collaboration. It's all in the cloud. Everybody can access it. You don't have to worry about exposing something through the firewall out onto the internet. You don't have to worry about the identity problem because it uses internet identities, so you don't have to worry about giving people accounts on your domain or on your TFS server or anything like that. Overall, it's a lower operations cost. We can benefit from economies of scale. We'll operate the server for thousands and thousands and thousands of people, and we'll be able to do it more efficiently that way. It gives us, a benefit to us, it gives us a better understanding of our customers. We actually know what our customers are doing. We know the kind of problems that they're having, and instead of, we ship TFS out there, we know a bunch of people install it, but we don't know exactly how many. We've got this thing called SQUIM, which sends back telemetry, but only if you agree to let it send back telemetry. So we know a lot of people don't. In fact, our data kind of says about 1 in 10 do, so 9 in 10 don't. So trying to figure out what people are actually doing is pretty hard. When it's in the cloud, we know what they're doing. We know what features they're using. We know what kind of problems they're having, and we can be much more adaptive to making sure we're delivering the capabilities that people want. It enables faster delivery cycle, so I don't have to worry about testing this thing to the absolute nth degree because I'm burning it in stone onto a DVD and shipping it out to 100,000 people each who are going to install it sometime in the next 2 to 4 years. And on who knows what OS, I can rev it frequently. Obviously, better not do that disruptively, but I can rev it frequently. And some of the things we're thinking about as we go into the future of TFS are going to be more amenable to publicly facing servers. Today, lots of TFS servers live behind the firewall. They're not exposed on the internet. There really isn't too many reasons to, because not that many people want to expose their source code to the internet. But as we think ahead and kind of the things we want to do to further improve the software development process, a lot of those involve collecting data from users and from people out there, I guess mostly users and operators, to better understand what they're doing and how they're doing it. So those are going to be very valuable in terms of having an easy way to do public-facing servers. So porting TFS to the cloud. The actual process of porting it was pretty easy. I think all told the TFS is a pretty big app. I mean, you figure it's about 100 and some people building it for like 9 years. So it's a pretty big code base. It's a lot of stuff. But porting it to the cloud, just getting raw TFS running up on Azure, it was like 2 months, 2 or 3 people. It was not very hard. The Azure's not that different from Windows. Windows Azure is pretty much like Windows, and SQL Azure is mostly like SQL. There's a few differences, and we had to change a few things. But getting it up and running in the cloud was actually pretty easy. The biggest part of what I would call the porting phase was dealing with identities, because TFS identities are pretty innate to what we do. We understand who users are, and we have permissions around them and all that kind of stuff. But when you go to the cloud, we wanted to support sort of the public internet identities, Live ID and Facebook ID and Google ID and all the great things that the Windows Azure Access Control Services support. And taking this deeply embedded notion of Windows identity, and we had Active Directory synchronization that would synchronize groups and organizational structure out of Active Directory, getting sort of all of that moved over to use ACS and the internet identity stuff was a pretty big deal. That was a major investment. It was a few people, probably 9 months or so. So it was a pretty big investment. Another area was not a huge investment, but was noticeable, was cost optimization. So kind of the monetary issues around running a service on premises where you own the hardware. This has a different set of constraints. The biggest one for us was on premises, your SQL storage and your blob storage is roughly the same price. It's just disks. You throw the disks in there, unless you do some interesting hierarchical storage thing, but roughly it's the same price. In Azure, it's not. So your SQL storage is a lot more than your blob storage. So one of the things we did was move all of our blobs out of the database and into Windows Azure storage instead of having it in SQL Azure. Not a particularly big deal, but there were a set of things that we did like that. And then lastly was account management. When you start thinking about a multi-tenant service and you're going to have all of those tenants managed by completely different entities with ultimately potentially different feature sets that they've chosen, there was a bunch of work to set up this notion of accounts and allow people to manage those. So here's the TFS on Azure architecture. It's similar to the current TFS on-premises architecture, but it sort of starts with the Windows Azure Traffic Manager, which is kind of the load balancer, as it were, for Azure. It's kind of the entry point into the data center that then routes traffic appropriately within the data center. That's relevant because we give you a domain. You get sort of your own what we call vanity URL. You can, like my account is minka.tfspreview.com, and the router knows about that and routes that to the right place. Then there's a set of web front ends, which are TFS application tiers, a set of job agents, which used to be on the application tier, but now have been broken out into separate batch processing systems. Then there's a set of databases, one database per customer, and a special database called the config database, which basically is, simplest way to think about it is it's the account database. It's the list of all of the accounts and tells you for the accounts which database to go look at to find their data. And then in Windows Azure Storage, we have diagnostics, and we have lots of diagnostics. In fact, I just approved purchase of, what was it? I think it was a terabyte of disk space for diagnostic data, and blobs, so your actual content, work item attachments, source code control, files, etc. And then access control services. So we actually use the majority of Windows Azure's features. Not every one, we're getting there. Give me another 6 months or so and I'll be using all of them, but we use the majority of them today. It's kind of the architecture, relatively straightforward port architecturally from the on-premises to the cloud version. So let's talk about the hard problems. And as I say, I've chosen three. Quality of service, otherwise known as QoS, cost of goods sold, COGS, and engineering cadence. So quality of service. So what's interesting about quality of service? Well, in the cloud, the service is always up. When's the last time you picked up the phone and you didn't hear a dial tone? Been a while. Dial tone's always there. Why? Because they run a pretty dang good service. Uncannily so, in fact. But in the cloud, people expect your service to be up. They don't expect it to be down for, quite honestly, just about any reason. They expect the reliability to be good, they expect the performance to be good, and they expect the data integrity to be good. Just to say, don't corrupt my data. Whatever I put up there, please give it back to me. And a big part, I'm going to do a little diatribe about SLAs. A big part of when we think about services, we think about a thing called an SLA, service level agreement. What is it I, as a cloud vendor, promise you in terms of the level of service that you can get? And I don't like SLAs. You have to have them, but I don't like them because I think it contorts the way we think about things. And I've seen it inside Microsoft, particularly, so I'll scope to that. I have seen it inside Microsoft. The problem is, what is an SLA for? What an SLA is for is it's ultimately a contractual agreement between the vendor and the customer that generally says, if I don't deliver you at least this good a service, then you're sort of justified in asking for some amount of compensation back, discount on service or something. So it's kind of a floor on, if I do worse than this, I'm giving you money back. Now the problem is, I find too often that kind of absolute worst case floor, once you've defined it and called it the SLA, becomes the goal. The goal is, I'll give you that service. And I'm like, no, that's not the goal. That's like the worst case. The goal is 10 times better than that. And I think it's really important as you think about a cloud service that you not be confused about that. The SLA is your butt covering measure. It's not your goal. Your goal's got to be way, way better than that. And as I say, I've seen too many teams get confused by that. And some teams are still confused by that, and I keep flogging them. So, components of quality of service. Let's talk about reliability. So Microsoft, we sort of have an across-the-board guarantee that our SLA says 99.9% availability. 99.9% is 43 minutes a month. Sorry, I should say 0.1% is 43 minutes a month. That is what, that's sort of the unscheduled downtime. Now, we distinguish scheduled downtime, maintenance windows, stuff like that, from unexpected downtime. So this is the reliability guarantee is all about unexpected downtime. So you get 43 minutes a month of unexpected downtime. It's less than it sounds like. So since we launched TFS, and I'll tell you this with some chagrin, since we launched TFS on the TFS preview in, what was it, September 14th or something? 13th? I don't remember the exact day. We've had the month of September, October, and November now, or at least a chunk of November. We have not yet met 99.9% uptime, including November, and it's only the 15th. So it's not as much time as you think. So as I think about that, let's look at the sources of downtime. There's a lot of them, is the problem. There's the data center. So the data center has some kind of guarantee of like how many minutes a year is the power going to be off, or some sort of fundamental catastrophic failure in the data center. Sometimes it's network routing in the data center. It's various things. A little anecdote, which is interesting. I learned the other day. So a friend of mine got to go out to one of the big, Microsoft data centers that's, sitting on top of the Grand Coulee Dam and sucking up all the power that thing produces. And he got to spend about a half a day out there touring it and talking to him and understanding kind of the data center dynamics. And he said something that he learned there, which as soon as he said it, I'm like, duh, that makes sense. Over the last 10 years, we've focused a lot on figuring out how to make data centers very reliable. Data centers, we talk about multiple power grids. We want to make sure that if there's a failure in a power grid, we've got a backup power grid. If both power grids go out, we've got backup generators. I was reading an article this morning about some data center that had like 3 megawatts of backup generator capacity, and on top of that they had backup generators in case the backup generators didn't work, and they had 150% of cooling requirements in case one of the cooling systems went out, and multiple redundant network pathways, and on and on and on. And what the world is slowly starting to realize is you can't do that. It's nuts. It's not cost effective. And in fact, what I heard, and this isn't official, so I'll take this with a little bit of a grain of salt, is that we're moving towards 2 nines data centers now. That essentially it's way more cost effective to build a 2 nines data center than a 3 nines or a 4 nines. Well, if the data center is 2 nines, how do I get to 3 nines? Well, the answer is it's got to be software, right? So I've got to leverage multiple data centers, and I've got to be able to dynamically deal with data centers coming up and down and having my service continue to be available. So data center is a source of downtime. SQL Azure, it's a big component we sit on top of. The cloud component of SQL Azure is V1, and we found quite a few issues with it. And that has been, that's actually probably been our number 1 source of downtime so far. ACS and LiveID have occasionally caused us some downtime. Windows Azure Storage, Windows Azure, the Global Traffic Manager. Oh, and by the way, TFS itself does occasionally have some problems. But when you add it all up, it's like 10 or more components that could fail. And if each of those 10 components has a 99.9% SLA, and that is the goal, what's the chance that the top component has a 99.9% availability? Answer is 0. Or, okay, not literally, but dang close to it. So there's a couple of lessons in that. One is back to your SLA is not your goal; it's the bare minimum, or worst case. And second is you got to be resilient to failures. Like if you depend on, and 10 actually is not very many. When you start to look at big cloud systems, many of them will have 50 or 100 or 200 services that they rely on, any of which could be down at any time. So you've got to build the system to be resilient to any one of those systems being down. Now, the data center being down is a pretty big deal to be resilient to, but even that you can be resilient to. Performance. I find all too often that as we talk about SLAs, performance is not considered nearly enough. And further, the goals are sometimes wacky. I was reading the Windows Azure Storage goals this morning. And in fact, I was checking it because I heard something. We hit an issue a while ago, and I heard an answer which just didn't make any sense to me. And before I said anything about it today, I wanted to go confirm that what I was told was right. We had a problem where we had a period, I don't know, it was like a half hour or something, where the system was unbelievably unresponsive. I mean, it just really like a minute to respond to anything. And when we went and looked at it, we found out that Windows Azure Storage was having an issue. They were having a problem, and we were seeing I/O times of like 30 seconds to read, just a block of data from disk. And we poked on it and called their operations team and said, "Oh my God, you're having a problem, and this is a big issue for us, and what's your plan, and how are you mitigating it, and how is this never going to happen again?" And kind of the initial response we got was, "Well, what do you mean? It's within SLA." Like, how can a 30 seconds to read a disk block be within SLA? Well, our SLA is averaged over the month. So as long as our average over the month is less than 2 seconds, everything's okay. I'm like, over the month. So I could be down for an hour and everything would be okay? That can't be right. We have some work to do there to improve our performance SLAs. Another one I found around performance is multi-tenancy. Multi-tenancy is a big deal. We hit issues with SQL Azure where this happened the day we launched it. There was some tenant on SQL Azure who happened to get co-located to the same database server that we did that was just beating the mess out of the server and sucking down all available capacity, and our service was effectively unavailable. And it was all because you had this other tenant on the same box sucking up all the resources. So if you're going to provide a decent performance guarantee in the face of multi-tenancy, you've got to have the ability to throttle, to control how much of your physical compute resources can be allocated to the service. And since that issue, the SQL Server guys have indeed added quoting systems so that they can quota what a tenant can use. Retries is another big issue. Cloud services, they're loosely coupled. Things can be up and down. There's all kinds of reasons why a component might be temporarily unavailable. You got to do retries, but you can't. When we first started having problems with retries, I had people looking at me like, "What's the problem? You're supposed to retry." I was like, "Yeah, but you don't understand. I'm having to retry." I one time just did the math to show them how much of a problem it was for me. And over about, I think it was a 6 or 7 week period, I spent 2,600 minutes in retries. I'm like, that's like hours and hours and hours sitting and waiting for retries. So sure, I get that you have to retry. That's part of the cloud architecture, is anything can retry. But frequency of retry matters. Like there ought to be some guarantee or some SLA metric about how often I have to retry, even though I understand I do have to retry. Next QoS issue is monitoring. It's incredibly important. We do 2 kinds of monitoring, what's called testing and production. So that's monitoring from within the data center it pings, I think, every minute just to check and make sure the server's still alive. We have another, what I call testing the web. Gomez, if you've ever heard of it, is a service that you can pay to have them periodically ping your service from all over the world and give you stats on performance and availability. And it's funny, when I went to go talk to the guy who managed the engineering system for Azure, and I was talking to him about monitoring and our approach and telling him what we do, he says, yeah, we really didn't use Gomez until just really recently. I'm like, really? Wow, I'm really surprised. Why don't you use Gomez? And he said, well, in my view, all Gomez is doing for me is telling me the health of the internet, because my testing in production, my production testing is telling me the health of my service. I know if my service is up or not. All Gomez is telling me is whether the connection between, Italy and my data center works, and what the performance of that is. And quite honestly, even if it didn't, I wouldn't be much I could do about it, because it's some ISP out there with the problem, not me. I thought that was an interesting perspective. I do still think it's important, and Azure does now do it. It's important to at least understand the experience your customers are having, both in reliability and performance, so that when they call with problems, you've got some idea of where to point them to. Because, again, remember, every problem is your problem. Granularity is interesting. Most services only do granularity at the whole service level. Sort of the holy grail of monitoring is to actually be able to do it at a per customer level, so you actually know for each and every customer what their what their service level is. That's hard, but it's kind of the goal. Today, TFS only does global, but we'd love to get per customer. Visibility I find really important. We put together a really cool dashboard, nice metro thing with graphs and tiles that gives you visibility into what's going on in the service at any time, and anybody on the team can go connect to it and see what the health of the service is, get CPU overhead, get requests per second, get memory, get availability, all that kind of stuff. And I'm now actually having monitors put up around the hallways just to instill in everybody, like, live site is everything. If there's a problem on the live site, go fix it now. Stop whatever you're doing and go fix it. One minor thing to keep in mind is monitoring has COGS impact. And maybe I should have put this on the COGS slide, but it is something you have to think about. The more monitoring you do, the more it costs you. Gomez costs you. Your monitoring facilities cost you. The logging storage costs you. And then a related thing I'm not going to talk much about is business metrics, but I throw it in the category of monitoring. Is we often think about monitoring as health, like, is the service healthy? But it's also really important to think about monitoring in terms of business metrics. What are the things that help you decide how to build a better product? I talked about better visibility into what our customers are actually doing, and that's what business metrics are all about. Understanding what features they're using, understanding where they're getting blocked, and you can use business metrics to give you that telemetry and understand what's going on. Diagnostics. You can't attach a debugger to production. You can't. That's not okay. Service will stop. People will be unhappy. It's ugly. So you have to go about diagnostics in a different way. First, you log everything. And I just mentioned I just allocated like a terabyte for logging data. You log everything. You log every request, every exception, every service interaction, how long it took, every retry you did, everything you log. Because that is the key data you have to have, because you are not going to get access to the live service. The other thing is I call tenant isolation, because occasionally you'll get a problematic tenant. And in fact, when we launched TFS, we were a problematic tenant. I'd mentioned to you we had some problems the day we launched with this other tenant that got allocated onto our database. And I learned something about SQL Azure that day. So we're there, and we knew it was a big event. We were launching at the PDC. There were thousands of people. We didn't know how many people. Like, we were saying, well, what happens if 2 people sign up, or 2,000 people sign up in the first 2 minutes? What is that going to do to the system? And we did all kinds of modeling around that. So we kind of had everybody gathered around the bat phone. I had people from the SQL team and people from my team and people from the ACS team all there ready watching in case something went wrong. And boom, like immediately something went wrong with this tenant getting allocated to our server. And so we're in a flurry. What are we going to do about this? How are we going to fix this? And they're like, okay, fine, here's what we'll do. We'll we'll move that tenant. The SQL guys, the operations guys have the ability to move databases from one server to another. So we'll move them off your server. So they started migrating these problematic databases off our server. And after they're like working through it, one's gone, next gone, next gone. And then all of a sudden, they start showing back up. And they're like, oh crap, didn't think about that. The load balancer has now started realizing that server doesn't have enough databases on it, so it started moving them back. And I was like, oh crap, what are we going to do about that? And they're like, there's nothing we can do. We don't have any ability to isolate you. It's a homogeneous farm of machines, and the load balancer just moves stuff around, and there's no way for us to say that machine, it's special, don't mess with it. So literally what we had to do the first day is disable the load balancer for the entire data center. Just so that we could keep the TFS service up. And then we had to go deal with throttling and fix that. Again, that's been fixed. It's good now, but I have a few ulcers. Another thing you have to think about with diagnostics is privacy. This is customer data. It's important. So like when I set this up, I had to do background check. I had to give a list of employees who were going to have access to customer data. We had to do background checks, and exactly those people have permission. And even then, it's only need to know, so you can only get access to the data. You have to perform some critical function. So one of the things we did, and I should have mentioned this with tenant isolation, is in TFS, we've architected it for isolation. So we actually have, I showed you that picture of we've got these app tiers and all these different pieces. We've got one of those that we call the debug instance. And we can pull any tenant off of the service onto the debug instance and then isolate and work on just that one tenant. We can attach a debugger to it. We can do we can update the code. We can do whatever we have to figure out what's going on with that tenant. And then once we've fixed it, patched the service, we can move the tenant back. So a lot of the things you have to think about when you think about diagnostics. Upgrade. Upgrade is huge. Upgrade is probably our single biggest problem. And by problem, I mean biggest problem to solve, not that it's actually a problem. I feel like we've done a pretty good job with it. Remember, the service must stay up. You want to keep your service up all the time. And what that means is even during upgrades. So I want to upgrade the software. I want to keep the service up. I don't want to take my customer down. Especially think about a big upgrade where I'm doing some big database schema change, and I've got 100,000 databases out there that need to be upgraded. The service could be down for a week while I get all those databases upgrades. So you can't take the traditional on-premises model, take the service down, do the upgrade, bring the service back up. You can't do that. So you really have to start with upgrade from the beginning. You have to design for upgrade. And we have some rules. Never break a contract. So contract is sort of the contract between any two components. You never break it. You might update the consumer to consume some new contract, then update the producer to produce that new contract, then deprecate the old contract. You've got to have this sort of dance of how you do updates so that at no point are you ever putting anything on the system that's incompatible with anything else. Which leads me to point number 2. Don't ever count on updating two components at the same time. Because it can go wrong, and I guarantee if it can go wrong, it will go wrong. You got to think about the ability to have rollback available. Different people have different views on this. Some people believe very firmly that you've got to have a rollback plan. If at any point an upgrade goes bad, boom, I can click a button and the upgrade comes back off and I'm restored back to previous state. That can be pretty hard when you start talking about schema changes and stuff. But some people take a roll forward mentality. Whenever there's a problem, I will fix the problem and keep the service going forward. But it's something you got to think about. Testing on real data. I think it's very important that as you're doing your upgrades, preparing for your upgrade, you're doing your upgrade testing on real data. And you've got to be able to do targeted and incremental rollouts. So if I'm going to do an upgrade, what I want to be able to do is upgrade just the accounts for internal Microsoft testers so that I can sort of make sure that works. And then when I get to the point where I feel like that's good, then I'm going to want to roll it out to the next 1,000 people and make sure that it works for them. And then I'm going to want to roll it out to 20% of the service and have a very controlled ability to roll out upgrades to increasingly large groups of people so you don't roll out the upgrade service falls over and everybody's in trouble. And you got to think about client updates. We have a client, so client is one of our components. We can't ever break that contract. So we've got a similar kind of staging issue between the database, the application tier, and the client. So kind of my advice, understand your dependencies well, avoid single points of failure, design for failure and recovery, start your upgrade design at the beginning, treat monitoring as a part of the product. It's not an afterthought, and log everything. I am running out of time, so I'm going to go kind of quick here. Cost of goods sold, the next problem. What is COGS? So COGS is kind of your variable cost to operate the service. For us, it includes our Azure COGS, compute, Windows Azure Storage, SQL Azure, ACS, Network I/O. It includes some softer COGS, our monitoring COGS, we call mock escalations. That's like anytime there's an incident in production, it gets escalated to these 24/7 people who can go look at and do triage of the problem before they decide whether to escalate it to somebody else. You've got an operations team to support, which divide the salary of a person by your number of customers by 12 months, and you suddenly realize that an awful lot of your COGS is the people operating the system, and your customer support, of course. And then don't forget your fixed costs, say your development effort, for example. To me, COGS is critical because COGS is fundamentally what defines what flexibility I have with my service. So when we first defined this TFS service, we had a mental model of sort of how much we get for paid accounts, what the ratio of paid accounts to trial accounts would be, and all of that. And then as time evolved, the market changed, prices came down, we wanted to do more sort of co-marketing things with platforms, and suddenly the whole equation changed, and our COGS equation didn't make sense anymore. And we had to go back to the drawing board and rethink the way we had designed the system so that we could support literally 2 orders of magnitude lower COGS in order to get to a kind of price point that we wanted to be able to do some pretty cool things. So like if I had one thing that I could go back and do over again, it would be that. I would go back and start from the beginning with a design point of drive my COGS as low as I possibly can. That's not that important, and I pretty much said that. And the last point I was going to make was engineering cadence. There's a lot of hard problems as you think about engineering cadence. And you go to cloud, you are... I've set, for example, for my team, our goal is to be able to update the service every week, once a week. And in fact, we do. We update the service about once a week. Sometimes it's just bug fixes. Sometimes it's new features. Sometimes it's major updates. But we update it every week. And, we're sort of moving away from the big bang releases. Develop for 3 years. Boom, here comes a big new release. We don't do that. We kind of... update the service as we build new features. And that has a bunch of implications. It changes the way you do planning, changes the way you do development, testing, release management. All your processes change. It's a big cultural change. It's a huge issue. So summary, cloud has a bunch of compelling advantages. The basic port is really easy. It's the service part that's hard. Quality of service, cost of goods sold, and engineering cadence are, I think, the big 3 problems. And that is that. Hopefully that was interesting. I thank you all for coming, and I hope you enjoy the rest of the week. By the way, there's a lab right down the hall where you can try out the TFS Azure service if you'd like. There's a bunch of PCs on there you can go to. It's www.tfspreview.com. If you need an activation code,
they actually got them. There was one in the bag, and it's very hard to remember. It's ALM Summit.
Ah, there you go. Please don't hand that out to anybody. Keep it for yourself. By the way, when you sign up, you will get your own personal, what we call social activation code, which is good for 5 activations, and you can give to your friends. So give that one to your friends. Don't give out the ALM Summit one. Okay?
Thank you, Brian.
Great. Thank you.